where the last video ended, but again, this is what we end up with. S of t is equal to t squared plus 70 plus 7t plus 62. Now, we can go a step further with it, and we can do an example where I'm going to tell you that a of t is negative 2. V of 0 is 6. And S of 0 is just 0. No, 10. S of 0 is 10. All right. So from here, I want to know my specific position equation. But to get there, I'm also going to solve for my initial velocity equation. So this is just going to be a multiple step equation. So what do you think I'm going to do to start off here? Not everyone at once. Again, if you're wrong, we won't laugh at you for more than 5 minutes.
Take that anti-derivative of the acceleration.
Yeah. My acceleration, I don't have a variable, but it is negative 2, right? So that would give me v of t. So v of t is the antiderivative of negative 2 dt. So v of t is equal to negative 2t plus a constant. Does that make sense? All right, now I need to figure out what this constant value is. So I know if I plug in 0, I get 6 as my answer. So 6 equals negative 2 times 0 plus my constant. So what is my constant going to be there? 6. My constant's going to be 6. So what's my velocity equation going to be? Negative 2t plus 6. All right, so now let's go to position. So position, I've got s of t equals to the antiderivative of what? Yeah, negative 2t plus 6. All right. So S of t is going to equal to
negative t squared plus 6t plus c.
Okay. So S of 0 is what? 10. So 10 equals 0 plus 0 plus c. So c equals 10. So my position equation here is negative t squared plus 6 times t plus 10. Any other question there? All right. Now again, based on this whole concept of plus c, we're going to talk about something called slope fields. Now, if my equation is let me try to think. let's do 6t squared dt. Or let's make it, this is going to be my t, and I'm just going to let this be y for lack of a better variable. What is the antiderivative of this? Would be 6t cubed, right, over 3 plus c, which would be 6 times no. What's it going to be? 2t cubed. That's 2t cubed plus c, right? Now, two t cubed's graph would look something like this. Now, what does it do to 2t cubed when I put the constant value with it?
It'll translate it up.
Or down, right? Depending on what c value is. So this is going to be a vertical shift here. So I could have this. I could have this. So forth. Every one of these equations has the same slope at every x value. These should all be parallel to each other in vertical. I know I didn't do a very good job of drawing that out. So this one equation has an infinite number of antiderivatives. So, taking that into consideration, look at page 276 in that packet. If you look at the graph in your packet, page 276, you see the graph of a line. And let's just say that that line is y equals 2x. But what we're going to do different with this line is we're not going to say that this is the graph of y equals 2x. This is the graph where y prime is equal to 2x. So every y value up here represents the slope of my original function. I'm going to say that again. Every y value on this graph right here represents the slope of my original function. So if this is the point one, 2, then that means in my original function where x equals 1, m is going to equal to 2. Now, that could happen here. That could happen here. It could happen up here. It could happen anywhere where x is 2. I'm sorry, where x is 1. Anywhere where x is 1, I've got a slope of 2. Likewise, let's just say that this is the point -2, 4. Everywhere that x is equal to -2, I have a slope of -4. I wrote that wrong. I think I said -4, but I wrote 4. So at -2, -4, everywhere I have a slope of 2, I'm sorry, everywhere my x value is -2, my slope is -4. So this is really steep. And right here, this is the point 0, 0, right? So everywhere my x value is 0, my slope is 0. Do y'all kind of see what's happening here? And this is going to produce a slope field. And what happens is, if you think about what the antiderivative is, what is the antiderivative of 2x? X squared plus c, right? So it's just regular x squared then it's going to look something like this. If it's x squared plus or x squared minus 3, then it's going to look something like this. So every one of these parabolas here has the same slope at the same x value. It's just, again, what we said earlier. We've got these vertical shifts here. And this plus c is going to give us our vertical shifts.